Thanks everyone for joining in. I'm Pablo Costa from Prescient Devices, and I'm joined by Travis Elliott from National Control Devices, or NCD. We have very exciting content for you today. The agenda, as we have devised it, is first Travis is going to give an introduction talking about their long-range wireless industrial IoT sensors and a company overview of NCD. And we'll have a Q&A right after Travis. And then I'll show our predictive maintenance template showcasing NCD sensors. And of course, in a very exciting live demo, which today is more exciting than usual, since a lot of the online services seem to be jittery, but we'll brave and we'll tempt the live demo gods. And then we'll have a Q&A at the end. So that's what we have in store today. And without further ado, I'll pass control of the webinar to Travis Elliott from NCD.
Yeah, Pablo, thank you very much for that introduction. And thank you to all of you who take time out of your busy day to join us on this webinar. My name is Travis Elliott with National Control Devices. I am a design, support, and sales engineer here at National Control Devices. So if you were to contact us, for any pre-sale related questions on our products, technical support related questions, or anything of that nature, I would be happy to speak with you. Not joined with us today is Anil Bhaskar, who is the CEO of National Control Devices. I believe he is here as an attendee, but he won't be presenting. But you may speak with him as well if you contact us. So without further ado, I'm going to share my screen here, and we'll go through a slideshow here. And at the end of this, we'll pause shortly for Q&A, and I'll be happy to answer any questions you have related to this presentation. So as Pablo mentioned, we will be presenting to you our industrial IoT range of long-range wireless sensors. It is an entire ecosystem. So we'll get into it here. So just a little bit about National Control Devices before we get started here. National Control Devices is a relatively small technology company consisting of approximately 20 employees. But that said, we have over 10,000 individual clients located throughout the world. Our average yearly orders are somewhere around the volume of about 4,500. So we don't have any trouble supporting large-scale clients as well as smaller-scale clients for smaller applications. We've been in business since 1995. So we are a very stable, experienced company. And most of the engineers here have more than 10 years of experience in our fields. So this is just to give you an idea of what our current client base ratio looks like. Approximately 74% of our clients are based in the United States, but we do have 26% are international. And I would hedge to say that we're moving more towards more of a balance between these two as we gain more international clients with our line of products. So this is just an overview of some of the industries that we work with. Manufacturing, think of large-scale manufacturing facilities, healthcare industry, energy conservation, oil and gas, automotive, structural maintenance. This line of products really appeals to a lot of industries throughout the world. And we can't list them all here, but if you look at the line of IoT wireless sensors and devices we offer, you can pretty quickly see how that could be applied to a very wide range of industries. So this is just a look at some of our clients that we've worked with over 27-year period at this point. We've worked with every Fortune 500 company you can think of, every division of the military, a lot of aerospace engineering companies. We're pretty proud of the large number of clients and the big name clients that we've worked with over the years. So why NCD? Experience. Like I said, we've been open since 1995. We've been designing and manufacturing electronic hardware in-house since day one. Our engineers here have got a lot of experience, and we've been doing this for quite a while. Everything is made in the US right here in Missouri. The nice thing about that is there's not going to be a lot of extended lead times. We're able to fulfill orders in large scale and small scale by manufacturing in-house. Data ownership. This relates to the IoT long-range wireless line of sensors. A lot of sensor manufacturers are going to basically have their own cloud platform, and all sensor data is required to be sent to their cloud platform. And then you can hook it over to other web or cloud services like Prescient. NCD does not take that stance. We are a hardware manufacturer, and our goal is to collect sensory information throughout your environment and then help you send it to whatever cloud platform you see fit. The ecosystem of products in the enterprise line, which is what we call our IoT long-range wireless products, is very extensive. We're over 80 unique products in that line of products. And it consists of everything from temperature, humidity sensors to tank level sensors to predictive maintenance sensors, vibration, energy monitoring, you name it, we probably have a solution. We have a lot of soil monitoring sensors, which is very good for the agricultural and grow industry. So you're more than likely going to be able to find something there. And if you don't, we'll be more than happy to work with you to custom design a product for your specific application. Another point is NCD is cloud agnostic. We are very excited to work with companies like Prescient. But like I said, we're a hardware manufacturer, and our goal is to create hardware that allows you to accomplish your application needs. And where you decide to send that data is completely up to you. But as I said, we're very happy to be partnered with Prescient, and I am a huge fan of their platform. Lowest cost of ownership. A lot of the sensor manufacturer companies won't actually sell you the sensor. They will lease it to you, and then you have to send the data to their cloud, and you have to pay that sensor manufacturer a monthly fee just for having the sensor. NCD is never going to charge you a monthly fee. Once you buy the hardware, it's yours, and we will back it with a 5-year warranty, a repair replacement warranty. And we've actually, over the years, we've actually repaired products that have been sent back from customers that had the devices for over 15 years. And if we're able to repair that product, we will do it. That's just part of our quality standard and our commitment to our customers. Secure end-to-end data encryption. So the long-range wireless protocol that our sensors are currently using, which is DigiMesh, supports encryption of the wireless transmissions. So you can't have, any way on site to sniff the wireless traffic coming from these sensors because they are encrypted. Once they get back to the IoT Edge Computer or the gateway device that would actually send the data to Prescient, of course, that has a secure connection with the cloud platform that's communicating with. So this is just another little recap of what we've sort of already covered on the previous slide, that we've been in business for 25 years. Everything's manufactured here in Missouri. And NCD provides an ecosystem of products to meet your needs. So This is sort of just an overview of the devices that are available in the enterprise line of products. Under sensors here, you can see we've got CO2 and air quality, vibration, pressure, temperature, humidity, light, and proximity. We've got a wide range of sensors available in that line. As I mentioned earlier, we do also do custom design. So if you have a need in your application that is not met with our off-the-shelf products, we're more than happy to work with you on that. And that's actually a lot of what drives the creation of new products in the enterprise line of products, is working with our customers to create the products they need. There are also some controller devices available in this line. We have relay controllers and DAC outputs. And of course, if you need something not covered there, we'd be happy to work with you on it. So this is just another overview of some of the more popular sensors in the enterprise line of products. And these are some of the available controllers available in that line of products. You'll see we have ProXR industrial relays listed here. That is a line of relay controllers that has been on the market for over 15 years now, and it is extremely solid. And this is sort of a overview look of what our enterprise line of wireless sensors looks like for the most part. You'll notice that there is NCD branding and graphics on the covers of all of these devices. But that said, we do offer white label customization of these devices. So we're more than happy to print your company graphics or logos on the tops of these enclosures to brand them to your specific company. That is a service that we offer to our customers. So now we're going to talk about the wireless capabilities of the enterprise line of products. These line of products, first off, operate primarily at 900 megahertz. Most of our customers purchase these systems with 900 megahertz wireless modules. Those 900 megahertz wireless modules are suitable for the Americas, Australia, and that region. But we do also offer 868 wireless modules, which are used primarily in Europe. And if 868 or 900 megahertz is not legal in your particular region for whatever reason, we do also offer these devices in a 2.4 gigahertz variant, although the range of those products is not going to be as far as the 900 or 868. Speaking of range, the 900 megahertz and 868 megahertz wireless modules have a typical indoor range of 1,000 feet or 2 miles for outdoor applications. Bhaskar and myself have actually gone out into the field, and we have tested these products and verified that they do achieve these range. We're not relying on the module manufacturer's ratings. Whenever we say they'll work 2 miles clear line of sight, they will actually work 2 miles. We've had a lot of customers install very large networks throughout very large campuses. There was a large automotive manufacturer who installed sensors throughout a campus that was over, I believe it was over 100 acres that the campus covered. There were some facilities there that were buildings over a mile long, and they were able to build a singular wireless mesh network to get all that data back to a single point. Speaking of mesh, these devices do have mesh capabilities, which means you can install repeaters throughout facilities to get the data from all of the wireless sensors in different areas back to a centralized collection point. And we'll talk about what that centralized collection point is here in just a little bit. So power capabilities. Most of the enterprise wireless sensors are battery powered devices. We just use AA batteries inside of them. They're high quality lithium ion batteries. But on those batteries, you can expect approximately 300 to 800,000 transmissions on a single pair or four AA batteries. So we don't give a time span rating to these devices, as in how many months or years they will last, because that's really going to be determined more based on your particular use case. Most of our customers will set the sensor report interval to something like approximately 10 minutes, which is the default we ship most devices at. So based on 10 minutes, you can calculate how long the devices will last based on the 300,000 to 800,000 rating of that particular sensor. Different sensors have different transmission count ratings. And of course, you can set the report interval of the sensors down as low as you like. Some devices like the vibration sensors and predictive maintenance sensors do have a minimum report interval just because there's a lot of calculations that have to be done on the device and it's more intensive. But a lot of things like temperature humidity sensors or current monitoring sensors can be set down just about as fast as you want. So I believe we've covered everything there. Oh, one other thing. While the devices are battery powered, we do offer external power options on pretty much any sensor. If you see a sensor on our website and there's not an external power option when purchasing it, let us know and we'll be happy to add that for you. So if you want to get away from batteries, that's completely up to you. So today, Pablo is going to be demoing some of our hardware. He's going to be demoing this industrial IoT wireless predictive maintenance sensor. We're on the third iteration of this product. We continue to make improvements and add new features to it. This device has built-in FFT analysis, which is phenomenal. No longer do you have to transmit huge amounts of raw time domain data from the device to your application or the cloud and then do FFT analysis. It can be done right on the device, which is going to save a lot of data, and it's going to save a lot of your wireless bandwidth, and it's going to save a lot of computation on the cloud side. Now, that said, this device does support raw time domain data. So if you really want that raw time domain data, this device can be put into that mode. It can be put into process data mode or FFT data mode, or it can be put into raw time domain data on demand, which means primarily it will send out process data, but at any time you can send a command to the device to request the raw time domain data. So that's kind of all based on the vibration probe, which you can see is a very nice stainless steel rugged probe. It comes with an optional magnetic mounting foot that threads into the end of that stainless steel probe. And the outside of that probe is a 1/4-20 NPT, which is very common on a lot of motors. A lot of times you can find a good place to mount that. In addition to the vibration probe, what makes this what we call a predictive maintenance sensor is we also have a current transducer attached to the device as well. So not only can you monitor the vibration of your device, like your motor or your pump you're monitoring, you can also monitor the current consumption of that device. Thirdly, there is a K-type thermocouple, which would be the brown wire in this photo. That's going to allow you to monitor surface temperatures of the motor, pump, or perhaps an adjacent gearbox that's being driven by the motor. So being able to accurately monitor temperature, vibration, and current is going to give you a very good snapshot as to the health of the device that you're monitoring. In conjunction with the predictive maintenance sensor, we're going to be looking at the industrial IoT Edge Computer. Now, this is the central collection point for all of the sensors. So think about your facility and how you'll have multiple sensors mounted throughout that facility that are broadcasting their wireless telemetry data at 900 megahertz or 868 megahertz. That data needs to come to a central point where it can be processed and then sent off to cloud services. That is the purpose of the IoT Edge Computer. Now, typically, people are always going to ask, well, how many sensors can I connect to an IoT Edge Computer? And to be honest, there is not a finite limit to the number of sensors you can connect. It's really based on bandwidth. So if you have, let's say, 500 sensors in a facility, and they're all reporting at a relatively normal interval of something like, say, 10 minutes, then, it's possible, an IoT Edge Computer could handle all those sensors at the same time. But typically what I'm going to tell users to be conservative and to be safe is that I recommend about 50 wireless sensors to each IoT Edge Computer. Now, another thing that can be done if you need to exceed that is you can install multiple IoT Edge Computers into a facility in the same environment. We can use the network ID parameters inside the wireless DigiMesh modules to separate the IoT Edge Computer and a group of sensors into an isolated network. So we can have multiple local networks of sensors that are isolated from each other. The IoT Edge Computer runs Node-RED, which we're going to look at here. Oh, and I should also mention the IoT Edge Computer has 3 connectivity options. It can connect to the internet via Wi-Fi, Ethernet, or it's available with an optional cellular connectivity options, which comes with a hologram SIM pre-installed. So yeah. The IoT Edge Computer runs Node-RED on board, which, if you're familiar with Prescient, makes us a perfect pairing together. This is a basic look at the flow that I would run on an IoT Edge Computer that would allow it to send data to Prescient. You can see just how incredibly simple this is. We have the wireless gateway node on the left, which is going to basically be where the parsed data from all of your wireless sensors comes out. It's going to come out of there, and it's going to hit a function node. And that function node is really doing nothing but setting the topic of the message being forwarded in order to report it to your Prescient account. And then lastly, on the right, we have a MQTT node, which is just connecting to Prescient via credentials they will provide to you and reporting the data there. So very, very, very simple setup. Now, you could do a lot more. You could monitor through this Node-RED flow, you could monitor the IoT Edge Computer's internet connectivity, the connectivity with Prescient's cloud via the MQTT connection. And if that connection were dropped, then you could log the data received from the sensors during that outage. And then as soon as connection to Prescient was reestablished, it could send all of that data to Prescient sort of in a burst mode. So that way you would never lose data. Also through Node-RED, you could create a local dashboard so that you could have a local interface for viewing the data from your sensors. Node-RED is just extremely powerful, and you can do so many things with it. So that's about it from me for today. If you have any questions, we're going to be more than happy to work with you and to help you in your IoT application. Feel free to contact Danny Bahosker or myself via email. And please feel free to visit ncd.io to view our entire line of products. So with that, I think we will move over.
We'll do some Q&A. So I have a few questions that have come in anonymously through the chat. I think maybe you addressed some of these. how many sensors can you connect to a gateway? You said about conservatively about 50?
That would be a conservative number of sensors, but it could easily be exceeded.
Okay. Let's see, the second question. The industrial sector has traditionally been scared of wireless sensors since the industrial environment is very noisy. Do you see that trend changing, and does your technology help to overcome those noisy environments?
Yeah, it's a good question. So a lot of manufacturing facilities have a lot of very noisy devices in there, motors, pumps, things of that nature. And they also have a lot of automated equipment. And most of that automated equipment operates on the 2.4 gigahertz frequency if it is wireless at all. So most of the time, whenever you go into a large manufacturing facility like that, they're going to strictly forbid you from putting anything in there on the 2.4 gigahertz band because they'll be worried about filling up that bandwidth. Now, the wireless modules that we use in our products are 900 megahertz and 868 megahertz. These frequency bands are extremely good with communicating through noisy environments. So don't think about them like you would Wi-Fi or Bluetooth. This is a very robust and industrial wireless protocol and bandwidth. I believe you may be on mute there, Pablo.
Yes, Zoom faux pas. When will the webinar recording be available? I believe it's going to be by the end of the week. You should get an email with a link for the recording. We have another question. Can your sensors connect to an existing building automation system using BACnet IP?
I think that would be possible. I believe that we have some customers that have done that. I haven't specifically worked with BACnet IP, but that is absolutely something that we would be happy to investigate with you, David. I do know that there are some BACnet IP libraries available in Node-RED. I have seen those libraries available.
Yeah, I don't know if we have a BACnet application in the Designer. So yes, it's supported by Node-RED.
Yep. So it shouldn't be any issue with an IoT Edge computer to interface with that system.
Yep. Okay. So there will be another opportunity for QA at the end too. So keep your questions coming as you have them. So I'll move to a short component overview of Prescient devices, and then show you the template demo. So what we do at Prescient Devices is to help companies realize the value of their edge data in two main dimensions. One is the scaling dimension, meaning the ability to program, deploy, and manage vast fleets of devices, and to do so really quickly. We're currently helping more than 50 companies in their digital transformation, going to Industry 4.0, and more than 100 engineers are using our system. And as a company, we have more than 20 years of hardware, software, and systems expertise, anywhere from transistors in high-speed mixed signal SoC to systems larger like networking equipment or 5G towers, and obviously very strong software too. So I think we're an ideal partner for any IoT project. In addition, we have more than 10 years of experience in IoT. Our previous venture has shipped more than 500,000 devices that are currently operating. So Prescient Devices is a great partner for any IoT project. So we help companies in three main areas. And going from left to right here, we first help companies create and deploy applications that can span from sensor to the cloud and data lakes. So at every step in that continuum. And so we typically say that our professional service team and a sufficiently trained engineer can build solutions under 2 weeks. We can make changes in hours or less, and we can deploy in minutes or less, supporting a wide variety of edge data sources, protocols as the BACnet that was mentioned, Modbus, a variety of protocols, and also hardware platforms. So once you have that, we allow and enable companies to work with the data. And that data can come from any source, anywhere, in the edge, in the cloud, or both. It's, as you'll see, it's very easy to shift processing from edge to cloud or from cloud to edge. And so companies with Prescient Designer can acquire, can extract, transform, analyze, and visualize data in dashboarding provided by Prescient Designers or external dashboarding tools. And then, as I said, after processing data in Prescient Designer, send data to wherever its endpoint is. Data lake, like Snowflake, or further processing with other tools. So another point is that we can run processes like AI engines, again, both in the cloud and the edge. So it's the same tool, it's the same environment that you use to program both edge devices and the cloud, and there's seamless communication between them. So what this allows engineers, and I should stress engineers, you don't need to be a software developer to use the system. It allows engineers that are domain experts to unlock the value that is in the data, and by as a byproduct to drive innovation. So part of the value is that we have a local platform that allows for, coupled with the quick deployment, allows for very fast innovation and iterations. We compared to alternatives way of developing edge to cloud systems, we are conservatively 12 times faster, and our implementations are probably 6 times lower cost than as the comparative alternatives. We're built on Node-RED, and itself, an array itself is built on Node.js, which are long-running open source projects that have been battle tested, not just in this application, by a lot of other applications. So what I'll show in a moment is a template that has 2 main paths, and both featuring NCD's sensors, and the top path featuring their wireless gateway. So what you see here at the top is the edge computer that that Travis talked about, and there's sensors connected to that edge computer. In this case, it's the predictive maintenance sensor. But as Travis mentioned, once you have that edge gateway deployed, you can add a variety of sensors with minimal installation overhead. So that edge gateway is broadcasting the sensor data through MQTT, and it goes directly, as Travis mentioned, to our MQTT broker, which is part of our infrastructure. We allow, obviously, if for data security or other reasons, a company has its own broker, it's very easy to work with that too. But it's very seamless just to use our broker, and you see in the flow that your program, it's very simple to use our own MQTT broker, and that data then goes into Prescient Designer for further post-processing and dashboarding. So that's one path. The second path I'll show is one where there's a more traditional edge computer, which has a USB wireless receiver connected to it, and so it can get the data from wireless sensors that way. And this device has Prescient Edge running in it, So you get all the advantages that are inherent with that, meaning that you can quickly deploy and manage that device as if you were physically connected to it. And so all the advantages of having edge processing there are available. But either of those two ways, you get the data into Prescient Designer, and it's homogenized so that there is no difference between one path or the other. So that's kind of to set the stage for what you'll see in a moment. And let me just show you here. So let me start by showing the dashboard, and this is what a normal operator would interface with. So there are quite a few sections. So I'll start with the thresholds. So these are the three parameters that Travis mentioned that the predictive maintenance sensor provides: temperature, current, as in electrical current, and vibration or acceleration. And what you see here are thresholds that can be set manually. And these are essentially the limits that you have, that someone has determined that there are limits past which an action should be taken. In this case, the action that is taken is to generate an alert table where you get information about what sensor is producing the alert, what is the physical quantity that's being producing that alert, in this case temperature, the value, and the timestamp. I should note that this is one example of things you can do once you detect there's an anomaly. Node-RED is, which we're based on, is extremely programmable. So obviously you can send a Slack message, a notification, an email. The possibilities are really endless in terms of what to do once you get an alarm. So that's the second piece of this dashboard. The third one is a sensor table where you have each NCD sensor has a unique identifier, kind of like a MAC address of a computer. And so you list all the sensors that are being auto-discovered, meaning once you connect the sensor to the gateway through this template, it will automatically appear in this table. And of course, they're sorted by sensor ID. Of course, these are perhaps not very meaningful, or you have to remember which sensor is which. So obviously you have the ability to, you click on the sensor and then you can rename it. So we can say, this is the sensor in building, to correct, building 1, and you click, and then it gets renamed. So you can more easily identify what sensor it is. And the third part, or fourth part, I should say, of the dashboard is are the plots. And you can see the quantities being measured in shades of blue and the thresholds in red. So for example, in this case, it's temperature, and the threshold temperatures that I said is 12 degrees. That's why this is all alarming. So, this is all dynamic, obviously. If I raise the temperature at some point, there's no alarms anymore because the temperature is set to a very high level. So, and of course, every time you click on a sensor, you get the data that is the historical data from that sensor. So I want to stress this should be considered a starting point. So this is what we provide customers for free in terms of predictive maintenance, but it's based on Node-RED. And now I'll show the flow that produces this, and you'll see it's very simple to enhance and modify. So here's the sort of, if you think about this, the code, the dashboard that we just saw. Here you have the NCD Gateway node. So this is a subflow. And I should go slow because sometimes in the recording Zoom drops frames, so things appear magically sometimes. So here you have the code in that subflow. You have the gateway node. This is a node that our professional services team has written to have a very tight integration with the NCD Gateway. So the options that you have are the broker that you want to use. In this case, the default is the one in Prescient Designer, but of course, as I said, you can add any broker that you want. And then you filter by gateway and sensor if you want to just look at one particular gateway or one particular sensor. So very easy to get the data from the gateway. And then we do some formatting to homogenize the data. We add a bunch of tags, and we send it to an InfluxDB database, which is the one we use to pull the data from for the historical plots. This is, as I said, node-RED, so it's very easy to just pull nodes from drag and drop from the palette manager, wire them, and evolve the application. So this is the first path. I should say that, so the NCD gateway. So if you remember, that was the sensors connected to the Edge gateway, getting data through the MQTT broker. Here, I'll show that we have an Edge device connected to Prescient Designer. It's actually in my basement, and this subflow has been deployed to it. You can see here that is running on the Edge device. And what is there? Well, if you go into this subflow, and again, I'm looking at the flow that is actually running on the Edge device. We have this wireless gateway node. This is a node that NCD has written. So first party support in node-RED provided by NCD, which ensures quality, and that this is not something that Hobbies has done. This is first class support. So the Edge device gets the sensor data again through the wireless connectivity, wireless receiver that's connected through USB to it, and then we do in this case a similar processing as in the case of the gateway. But of course, since this is connected to Prescient Designer, you can modify and deploy very quickly. So that's those are the data sources, and then there are a few more sections. One is to deal with the sensor table. This is the one that actually allows for display and renaming of the sensors. This is the area for the chart management, and you see the three nodes that produce the plots for temperature, current, and vibration. And this is for the layer table. But as I said, if you want to do more analytics, for example, you can throw in the anomaly detector and say, sorry, cut it, put it on the Edge app. You can just modify it once the formatting is done. Just do it quickly. You can cut like this, and you add an anomaly detector in the middle. This is a node that our professional service team has developed. You have many options, but for example, you can have a pattern violation, a threshold violation, something that goes above a relative standard deviation. And this is just one example of the many more analytics that you can do to process the data, in this case at the Edge. But if you do it over here, it will be in the cloud, and you can just cut and paste these nodes to move processing from Edge to cloud, which is very quickly and very powerful. So in the interest of time, this is what I had prepared for today, and I will allow some times for some Q&A. But before I do it, I'll, if you didn't get enough of my dulcet tones today, we have an upcoming webinar with influx data. That's going to be January 18th at 8 a.m. and you see the details there, and I will continue to publicize and let you know more about it once it gets closer and the data gets closer. But that's our new webinar. And so I'll open up for Q&A now. Okay, so by Jeffrey says, can you explain what you mean by homogenize the two data paths? How? Okay, so what I mean is, let me make it back to my browser. So this is perhaps less of an issue with NCD sensors because they're the data coming out of the sensors is, regardless of the sensor, has a very common and consistent structure. But if you, let me go to this gateway here. So here in the format, for example, so what you're doing here is adding, in this case, we're just adding properties. We're saying, okay, so the received property is going to have the timestamp, the type on this message is going to be the sensor type's predictive maintenance, the device ID is meaning what gateway is coming from, what's the sensor address. So you're essentially putting data, the schema, essentially the data schema, you're setting data schema. And with NCD sensors, I say it's kind of lightweight because they do a great job to begin with. But imagine that you have sensors from different manufacturers or sensors that don't, like they're dumb sensors that you just read the output from an ADC, and you have to do all that by yourself. You can do it here. So once the in this subflow, so once the data comes out of this subflow, it's in a very consistent schema, and you can do it at any point. So in this case, it's the gateway. This is running in the cloud, but obviously you can do it in the Edge app here in the Edge device. And so by the time the data either goes to the cloud or you store in a database, it has a very consistent schema, regardless of what source it came from, or what sensor came from, what manufacturer it came from, and so on and so forth. So that's how what I mean by data homogenization. It's more, I should say, the schema is homogenized. Let's see. So I have another question. How and where is the sensor data timestamped? Okay, again, this is the case where NCD, with NCD, you pretty much have to do nothing because the data packet coming out of the NCD sensor has a timestamp, which is the actual time when the data sample was produced. If there are other sensors that don't have that timestamp built in the data packet that they produce, the first stage that here where it says check type, that the first node that you hit after the data comes out of the sensor will be, we typically put the timestamp there. Not as accurate as the NCD sensors, but that's the best you can do with those sensors. Let's see another question. What type of devices do you support? So we have three ways to install Prescient Edge in devices. We have a native version, which essentially runs in anything that is Debian-based Linux, which obviously includes Ubuntu. We have a Docker container for Prescient Edge. We have a Snap Prescient Edge, and Snap is a lightweight container scheme that is being pioneered by Canonical, the makers of Ubuntu. However you want, all those three options are in play, and then what you can install them on are, we support a wide range of devices, anywhere from PLCs, from Bosch, Phoenix Contactor, Nwago, Edge gateways. So really, we support a wide variety of hardware, and we're sort of agnostic as to what hardware it is. As long as you can install Prescient Edge, it works. And we typically recommend half a gig of memory for better usability. We can run with less, but it's just a matter of usability at that point. And another question, is your platform compatible with machine learning? How simple, difficult it is to incorporate a machine learning model for prediction? So Prescient Edge, by default, we we install TensorFlow in it. And so, and Node-RED has a node specifically to make it very easy to work with TensorFlow. So that's an option. However, we do realize that a lot of companies have their AI engines in containers, and which is a very typical application. So we have a container management template that you can use to manage those containers, and there's no problem. You install the container in the Edge device, and we can, from Prescient Edge, we can do pre-processing and post-processing. So essentially get the data in the format that, and in the manner that the AI engine will have its best accuracy before it goes to it. And then after the inference has been done, we can do a lot of post-processing and customization depending on the customer. So that's, yeah, we have again, we have another template, a machine vision template that you can install once you have a Prescient Designer account. That shows one example of how to do this at the edge. Which leads me to another comment. If you're interested in trying Prescient Designer, we have a community edition, which is free for life. There are just a few restrictions. One is that you can't have more than 2 machines, and if you don't use it for 24 hours, it will turn off. But you come back and you turn it on. There's no data loss. So that's a great way to evaluate the tool and also develop. So you develop your application, and it's free until you start scaling, obviously. Let me see. So I think those are the questions that I see. So, well, so I think we're almost at the top of the hour. So I thank everybody for attending. I reiterate that you'll receive an email with when the recording is available, and we expect that to be before the end of the week. And please sign up for our new upcoming webinar. It's January 18th with Influx TV. So that promises also to be very interesting. So with that, I thank everybody for attending, and have a good rest of your day.